This is the basis of Ken Shatton's prediction. The red line is the strength of the polar magnetic fields on the Sun, and the blue line is the strength of the toroidal magnetic fields. During a sunspot cycle, polar magnetic field strength is converted to toroidal magnetic field strength and back again. Sunspots form from the toroidal magnetic fields breaking through to the Sun's surface. The black line sums the polar and toroidal magnetic field strengths. This has been in downtrend since the early 1990s. This downtrend means that there is much less magnetic force available to make sunspots, so that solar cycle 24 will be much weaker than solar cycle 23. Combining the rural US data set we saw earlier and the projected temperature decline response to weak solar cycles 24 and 25, this graph shows the expected decline to 2030. The temperature decline will be as steep as that of the 1970s cooling scare, but will go on for longer. Now, it can get worse than a repeat of the Dalton minimum. Ken Shatton is the solar physicist with the best track record in predicting solar cycles. His work suggests a return to the advancing glaciers and delayed spring snowmelt of the Little Ice Age for an indeterminate period. No. I would be doing you a disservice if I left you with the impression that sunspots and solar cycles were the only manifestations of varying solar activity. This is a graph of the AA index, which is generated by the solar coronal magnetic field strength. The AA index was first measured in 1868 when the Earth was still in the Little Ice Age. The long-term increase in the AA index in the 20th century, which you see bound by the green lines there, corresponds to the warming of the 20th century. The 1970s cooling scare corresponds to a break in the uptrend of the AA index. Post that, the record is flat, corresponding to the satellite temperature record. What is of interest is what is happening right now. 2006 and 2007 are 2 years of low values, as opposed to the normal 1 year of minimum over the past 3 cycles. And we're still 2 years off solar minimum. In the fullness of time, it might be demonstrated that the AA index is more important than solar cycle amplitude in controlling the Earth's climate. But solar physicists don't predict AA index, and they do predict solar cycle amplitude. One earthly manifestation of the changing geomagnetic index is the galactic cosmic ray count. This is the count at Boulder, Colorado, since measurements were first made in 1953. A strong geomagnetic index deflects galactic cosmic rays from the inner part of the solar system. Work by Danish researchers has demonstrated a connection between galactic cosmic rays and low-level cloud formation. Clouds have an albedo of 60 and thus are more reflective than ocean or ground. The more clouds there are, the more reflective the Earth is and the lower the temperature. This theory also explains why Antarctica has cooled since the early 1980s. Snow and ice have an albedo of 80 and thus are more reflective than clouds. Less cloud over Antarctica makes it colder. The 1970s cooling scare, which you see there, coincided with a higher count at solar cycle maximum of solar cycle 20 and an extended period of higher annual counts at the following minimum. The galactic cosmic ray and low-level cloud connection is powerful enough to do anything required of it. Anthropogenic warming is real. It is also minuscule. Using the Modtran facility maintained by the University of Chicago, the relationship between atmospheric carbon dioxide content and increase in average global atmospheric temperature is shown in this graph. The effect of carbon dioxide on temperature is logarithmic, and thus climate sensitivity decreases with increasing concentration. The first 20 ppm of carbon dioxide has a greater temperature effect than the next 400 ppm. The rate of annual increase in atmospheric carbon dioxide over the past 30 years has averaged 1.7 ppm. From the current level of 380 ppm, it is projected to rise to 420 ppm by 2030. It's a transmission from the stratosphere to space from 279.6 watts per square metre to 279.2 watts per square metre. Using the temperature response demonstrated by ESO in 1990 of 0.1 of a degree centigrade per watt per square metre. This difference of 0.4 of a watt per square metre equates to an increase in atmospheric temperature of 0.04 of a degree by 2030. Increasing the carbon dioxide content by a further 200 ppm to 620 ppm, projected by 2150, results in a further 0.16 degrees centigrade increase in atmospheric temperature. Since the beginning of the Industrial Revolution, increased atmospheric carbon dioxide has increased the temperature of the atmosphere by 0.1 of a degree centigrade. This graph takes the data from the previous slide, illustrating the logarithmic effect, and condenses it down to one bar of data. Anthropogenic carbon dioxide is calculated to have contributed 0.1 of a degree per date. The entire anthropogenic effect up to 1000 ppm is good for about 0.4 of a degree in total. This graph shows the calculated contribution of carbon dioxide to atmospheric temperature over time. It has been 0.1 of a degree to date, and over the next 200 years will amount to 0.4 of a degree in total. It is scaled against the 2 degree temperature range experienced in the 20th century. The graph assumes that atmospheric carbon dioxide will continue to increase at 1.7 ppm per annum. The projected increase is likely to be brought forward if Chinese economic expansion continues for the next 10 years at the same rate that it's demonstrated over the last 10 years. This graph shows emissions of carbon to the atmosphere by the United States, China and Australia, with historic data from 1906 to 2005 and a projection to 2020. Chinese emissions will overtake US emissions in 2008.
I've already done so.
Thank you, Ray. Thank you. And then double from the current level by 2016. Per capita emissions by the three countries will be equivalent by 2020. This graph shows what the temperature would be with and without the warming from anthropogenic carbon dioxide. The anthropogenic effect is able to be calculated, though it is very small relative to natural variation. Carbon dioxide is not even a little bit bad. It is wholly beneficial. This graph from a recent INSO paper shows plant growth response to atmospheric carbon dioxide enrichment. The 100 ppm carbon dioxide increase since the beginning of industrialisation has been responsible for an average increase in plant growth rate of 15% odd. The 50% increase in plant growth rate due to a 300 ppm increase in atmospheric carbon dioxide can be expected about the middle of the next century. What a wonderful time that will be. A 300 ppm increase is something we can only dream about, but some future generation will get these sorts of benefits from the current industrious burrowing of the Chinese in their coal mines. C3 cereals include wheat and C4 cereals include maize.